Hello and welcome to the ChronicleFIX Cloud Native demo. So what I'll show you in this demo today is ChronicleFIX configured in HADR mode, deployed to a Kubernetes cluster. As you can see from the diagram, there'll be 3 instances of ChronicleFIX. They'll be connected together using queue replication to ensure that state is replicated around the cluster, and we're using console in this example to perform leader election. We have a client fix engine which will connect to the leader, send new order singles and receive execution reports. As well as that, we're using Prometheus and Grafana to surface any metrics and monitoring from these things. So without further ado, I'll jump in straight into our Kubernetes cluster. I'm using Lens to look at the cluster, and what you can see here is you can see a bunch of console pods, some Grafana and Prometheus pods, and 3 fix engine pods. You'll see there's a warning against the 2 follower fix engines. In this case, console has decided that fix engine 2 is the leader, and that has all 4 of its containers started. The follower pods only have 3 of the 4 containers started. The way that we've designed this demo is that the fix engine is not started on the follower pods. If we jump over here to Grafana, we can look at the replication dashboard. And at the top here, you'll see network bandwidth. So you'll see read bandwidth on the left and write bandwidth on the right. And you'll see that the leader fix engine 2, is writing at about 9 or 10k per second. And the followers are reading at about half that per second. The fix engine 2, the leader, is also reading. That's because we've got replication set up in acknowledge mode. So that's the axe coming back from the followers. You'll see here some other stats which queue replication exposes. So message rate per second, we're doing 20 consistently. We got the replication round trip time, so that's the time from the replication message being sent and the ACK coming back. This is shown here at 99th percentile on this graph, and the numbers aren't particularly good. That's because it's not a performance tuned demo and it's not designed to show performance. The other thing which is useful, which you can get out of queue replication, is how far behind the replicators are. So at polling time, the replicators are exactly 0 messages behind the master queue. So as well as that, in the fix engine dashboard, again, these are just examples for the demo. There's a bunch of other monitoring information which you can surface here. But what we've shown here is some various latency stats from inside the fix engine. Again, the numbers aren't great because I haven't done performance tuning, but you get the idea and the value of them, I hope. So what we're going to do now, we'll keep an eye on the client here, which is busy sending and receiving its new order singles. Let's just show you where we are. That output should come every few seconds. What we're going to do now is we're going to go over here and we're going to kill the master. Now, Kubernetes or Minikube will take a few seconds to kill the master, but what we see when that happens is that it will go down, Kubernetes will recreate it, and console will elect a new leader. So you can see now it's disappearing, it's going down. You can see the client over on the left has lost the connection and is round robining around the hosts, and fix engine number 1 has now been elected as the new leader. The client has connected to it and has restarted sending messages. No exceptions from the client. The only thing there you can see is the new logon message when it reconnects, and the fact that we got no exceptions from that client means that we can be confident that no messages have been lost. If we go back to Grafana, you can see now, so fix engine 1 is now the master. You can see that fix engine 1 is now writing at about 9.5k per second, and fix engines 0 and 2 are reading at about 4.5k per second. You'll also see, if you look in here in the fix engine dashboard, the various latency and network bandwidth numbers drop out while the fix engine is down and while the new fix engine is starting up. And because we don't have warm-up configured on these fix engines, ChronicleFIX, as you know, has got a warm-up configuration that you can use. You'll see that the new fix engine is slower when it restarts, but you'll also see that, of course, these numbers are gradually going down, and in a few moments it'll be back to the same speed that it was at before. So that's there's a few other things you can do with this demo, which I won't show you because they involve dropping the command line. But you can, for example, tell Kubernetes to scale up and scale down this Fix engine cluster. So I could tell it to scale the cluster up from 3 to 8 Fix engines, for example, if I wanted. And that's just easily accomplished with just one command line. So that's the demo. Thank you very much.